fourth case of partial fractions. So the third case is where we had an integral and we had some irreducible quadratic factors in there, and those were repeating, or those were non-repeating, those were discrete factors. So in this video, we want to look at the final case of partial fractions, and this is where we look at integrals where we have repeated quadratic factors in them. And you remember kind of what the deal was if we had some sort of something like let's say 1 over 1 plus x squared. You would need to do 1 over 1 over 1 plus x plus 1 over 1 plus x squared, and you would need to repeat it out. So we're going to look at the fourth case again and see some final examples for integrals with this partial fraction decomposition method. All right, so let's have a look. And it's also important that we remember that arctangent antiderivative thing. So case 4, denominator has repeating quadratic factors. So let's look when we have repeating quadratic factors. We can rewrite p of x over q of x as being equal to a sub 1 of a sub 1x plus b sub 1. And then I should have written this more generally in the last video, but I didn't. But let's write this as a full trinomial. So a sub 1 x squared plus b sub 1 x plus c sub 1 all the way up to a sub n x plus b sub n over a sub n x squared plus b sub n x plus c sub n all to the rth power, given that we are repeating r many times. All right, so now that we've done all this abstract stuff, why don't we go look at an example. So I would like us to integrate negative x cubed plus 2x squared minus x plus 1 over x times x squared plus 1 times x squared plus 1 dx. Okay, so as you can see, we don't need to worry about synthetic division because our dominating term here is something on order 5, so we don't need to worry about that. All right, so now why don't we have a look at decomposing this messy integrand. So we set negative x cubed plus 2x squared minus x plus 1 over x times, we can kind of combine this here now, so we have x squared plus 1 quantity squared, and then we do our little thing, we do a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 quantity squared. All right, so now we want to multiply everything by the lowest common denominator. This gets pretty repetitive. We've been doing this for the whole time. So get p of x. I don't want to write all of this out because then we're going to need to separate this whole thing into 2 lines. So we're just going to call this like p of x. So that's our numerator. So p of x is equal to a times x squared plus 1 squared plus bx plus c times x squared plus 1 plus dx plus e times x. Whew. All right, now let's expand all of this and we'll make this all nice. We get a times x to the fourth plus 2x squared plus 1 plus b times x to the fourth plus 2x plus c times x cubed plus x plus dx squared plus ex. All right, now let's put everything in terms of our different orders. We get a plus b times x to the fourth plus c times x cubed plus 2a plus b times plus d all times x squared plus cx plus c plus e times x plus a. Okay, that was a mouthful. Sorry if I jumbled everything. All right, now let's look at our system of equations that we can get from here. Remember, we match everything here onto our orders on the numerator, p of x. So from this, we get a big system of equations, and I'll rewrite this with the bracket system that I like, but we didn't have enough room. So we get a plus b equals 0. We get c equals -1, 2a plus b plus d, 2a plus b plus d, c plus e equals -1, and a equals 1. And I believe that we should have some equality at the 2a plus b plus d term. So let's fix that. So let's have a look. So it turns out that we want to set that equal to 2. And again, we're given a pretty nice system of equations. So we're given A and we're given C. We can plug all this in and we're going to be able to find our other values lickety-split. So we get thus A equals 1, B equals -1, C equals -1, D equals 1, and E equals 0. Okay, so now we can rewrite our partial fraction. So we get negative x cubed plus 2x squared minus x plus 1 over x times x squared plus 1 quantity squared is equal to 1 over x plus 1 over x squared plus 1 plus x over x squared plus 1 quantity squared. Now we can rewrite our integral. We get the integral of 1 over x plus 1 over x squared plus 1 plus x over x squared plus 1 squared. All right, now what we're going to do something similar to what we did in the last example, where we're going to be splitting things up here, and we should have a minus sign here instead of a plus sign. So we are going to decompose this fraction here, and that's pretty easy. We just take the difference. Then we get the integral of 1 over x minus x over x squared plus 1 minus 1 over x squared plus 1 plus x over x squared plus 1 squared dx. Now this is an ln integral, that's a u sub integral, that's another, that's an arctangent integral, and that's another u sub integral. All right, so let's do all this out, and we're going to get natural log of absolute value of x minus 1/2 natural log of absolute value of x squared plus 1 minus inverse tangent of x minus 1 over 2 times x squared plus 1 plus c. All right, that's all we got for partial fraction